Hello, listeners. Welcome to another episode of The Circuit. I am Ben Bajarin.
I'm Jay Goldberg. Welcome to the Awesome.
As promised, we have a special guest today. We are pleased to be joined by Calista Redmond, the CEO of RISC-V International. Hello, Calista.
Hello, thank you so much for having me.
Great. Thank you. Thank you so much for joining us and welcome. So could we just maybe start off? Could you just tell us a little bit about yourself? What was your journey to get here and sort of what you do?
Of course. So today I'm the CEO of RISC-V International. RISC-V International is the home and sort of the steward of the RISC-V open standard instruction set architecture. I know that sounds like a lot, and it is a lot. We are a community of stakeholders and members who are driving that open standard forward. Prior to RISC-V, I spent about 12 and a half years over at IBM and had various roles there in the hardware side of the business, culminating in several open hardware initiatives, as well as ecosystem cultivation with a final role there as a VP ecosystem in the mainframe part of the business. And then before that, in the long ago past, I was an entrepreneur. So kind of understanding the spectrum of challenges and needs from new companies all the way up to multinationals.
Very interesting.
Excellent. Excellent. So we have talked about RISC-V quite a bit on our podcast. We've actually talked about a lot of architectures, but there are many that are known, right? I think many listeners in our community get x86, they get ARM, they know sort of what those look like, what they can do, and who's doing what with them. So we're excited to talk a little bit more about RISC-V because I think there's a lot less of a broad understanding, if you will, at least in outside of technical circles, where I certainly see a lot of this gets discussed. But there's some value propositions around RISC-V, right? That it is very open, and there's a lot of dynamics of that are super different. And I'm not sure that I've really encountered this idea of what does it mean to have a truly open architecture. So I would just sort of love for you to kind of expand upon that, because maybe it's not new, but regardless, I think there's elements of this that are super interesting. So how does that operate? Like, how does that work when people think about, or when you think about this idea that it's an open architecture?
Yeah, well, first I'll leave you with a fun fact, and that is that there have been more than 50 architectures over the last several decades, but of those, ARM and Intel have sort of taken, the entire enchilada. I mean, they absolutely have nearly all workloads, save for those who are starting to build on RISC-V. And, RISC-V is a open standard, and that's different than open source software. An open standard, think of it like Ethernet. Once upon a time in the networking and data center business, the same folks that you got your server from also provided all the networking in between because it was proprietary. And along came Ethernet. Ethernet is a global open standard. And now everyone can kind of plug and play whatever they like onto that Ethernet-based network, and you're no longer locked into just one vendor or solution because of that. So, standards work a little differently than open source software in that, standards are frozen. There's not a ongoing continuous change, updates, patches, because it's hardware, right? When you get to, a significant change or a patch or an update, that's called a product recall. And you don't want that. If you have hardware, you don't want to have to do a recall, right? So you want to work off of global open standards that are frozen. So, the way that works behind the scenes is that a group of us get together, anyone actually may join, to get together to develop and cultivate what those standards are. They're, agreed upon, ratified, and frozen for the test of time. And that, then you can build strategically for decades to come on that frozen standard. You can build products that combine open building blocks. You can add your own proprietary extensions, and then take your product to market. Which is, similar to any open play, is that you take those shared common building blocks and then add your differentiation on top of that and go to market. And, with luck and a lot of thought and insight, you become wildly successful with your, differentiated solution.
I think this contrast, or at least I guess perhaps a misconception, right, about what open standards versus open sources is a really important distinction, because even today, and a lot of the write-ups I've seen recently from people tweeting about this or writing about just RISC-V in general and some of Momentum, still refer to it as open source. And I do think, right, there's an element of this that anyone can go and acquire, which is why I think they feel like it's a open source-ish kind of thing, but they miss that abstract, which is that there is a committee actually defining what this is, and then it is what goes open for everybody to sort of understand. Is that a good distinction of just kind of from a technological standpoint, right? Architecture, how you would sort of make that distinguish between open standards versus open source?
Yeah, it's exactly it. And think about the Bluetooth or the USB jack on the side of your laptop. Do you want every manufacturer going off and changing how that works? Or would you like your USB stuff to plug and play into any other USB stuff, right? So that's where standards are a lot different than open source software, which, has a lot more nuances and updates that you can apply to that. When, your phone has an update and you want to continue using other software on your phone, there may be updates to that too, but they continue to interoperate because you can change that software more readily. And those are some of the things that kind of distinguish standards from software.
So along those lines, a common concern or complaint we hear from people is that RISC-V, by being so open, risks getting fragmented, and such that everybody's RISC-V is a little bit different. Does that hold any weight? Is there any risk of that?
Well, it's sort of a fun piece of FUD, right? So, there's all these misconceptions out in the market, and some of them are kind of seeded by competitive interest to, folks that want you to use their architecture instead, which is fine. That's a business interest. But, there's a distinction here too. So fragmentation happens when there are multiple folks trying to do the exact same thing. So you have multiple interests going on in parallel that, everyone's trying to say, hey, I've got, I'm going to make a car and we're going to put the steering wheel on the left side. Oh, well, I'm going to make a car. I'm going to put the steering wheel on the right side. So you cause a little bit of headache for everyone else in the world. And, we haven't all agreed in the world on which side the steering wheel goes on. But that's fragmentation. That's doing the same thing different ways. Now, RISC-V does not prescribe that. We are very modular in how we build, and you can compose, your SoC based on those building blocks and compose it from the frozen pieces that you wish to use. So we focus here and foster diversity. That's doing different things using the same component. So, one person wants to build cars, the other person wants to build airplanes. They both need tires. So let's all use the same standard kind of concept behind tires. You have hubs and, various locking lug nuts or whatever. But you conceptually use the same things. You just compose that in different ways to tackle different challenges. You don't want the same tires on your car that you're using on your airplane, but you're using the same design principles. And that's kind of where this comes down to. So doing different things, but using similar common building blocks, that's diversity. Fragmentation is where you decide to have, multiple different ways to do the exact same thing. And by the way, other architectures have multiple ISAs. RISC-V, on the other hand, has one, and we're only going to have one. And RISC-V wasn't, just born yesterday. It was actually cultivated in the 80s. And the reason it's called RISC-V is it is the fifth version and final version of the original RISC architecture that came out of Berkeley. And by the way, ARM has a RISC-based architecture, and Intel has a CISC-based architecture, and that's I'm sure perhaps a whole nother show in itself. But it's not a new architecture. In fact, it's sort of the hardened version, modular version, rather than incrementally built version that really is unleashing the level of innovation we see and the design freedom that is now is higher in demand based on the different areas where compute processing is being called for.
And what kind of mechanisms does RISC-V International or the community more broadly use to keep everybody aligned?
Well, we have a pretty strong process and governing policies around how each extension or piece may be proposed, worked on, collaborated on, and brought through to ratification. So, similar to other open models, it isn't just everyone can throw their code up and away we go. Work groups get composed and organized around shared interest areas, and in some cases you may have a starting point that's been contributed by an organization. In other cases, you start working with the experts in that field to develop what that extension or specification could be. And then that goes through approval processes at work group and governing body levels, and final ratification by the board of directors. So there is a governing process, and we have a hierarchy and org chart of horizontal as well as vertical areas, ranging from security to different functional areas that we work on. We have about 70 different work groups going today. As well as several horizontal committees that oversee, things to keep those working in concert, right? So the governing of all of these work groups takes a lot of orchestration to ensure that the decisions or proposals by one group don't run into conflict with another group.
Got it. So, moving beyond the architecture, what about software? Because I've worked in data center. I've spent a lot of time trying to get ARM into the data center, and third-party software was a very big barrier, a big sort of speed bump along that process. What's happening on the software front? How do you encourage third-party ISVs to get involved? How's that progressing?
So there are a couple of naturally occurring forces. First of all, if you're designing a chip, you don't want to go too far off into the weeds in which would require you to have your own software stack independent of the community software stack. So by the way, that's a force working against fragmentation. And then second, no single company or country or anyone can really afford to build their own entire software stack. Those days are long gone. So, by having an open standard, anyone can bring their software to the RISC-V architecture, and that enables choice. It diminishes vendor lock-in. It provides growth opportunities for a lot of the software in the ecosystem to truly, optimize for RISC-V. Not just run on top of a black box, but rather to, fine tune to the nuances that RISC-V has to offer. And we have a lot of tool chain and operating system support already. And further, unlike some of the other architectures, we only have a single hypervisor standard. So that really simplifies and unifies a lot of our application support. And today we have thousands of developers that are working on this. Part of being in an open ecosystem with an open standard is you benefit from the collective investment, not just of cash, but of engineers that have shared collective interest in the success. So, if you're sitting in a software application group or say an operating system, it's in your interest to run on all of these architectures, because that's business opportunity And once you port to one, it's pretty low barrier to port across multiple different architectures. And that's true of RISC-V as well. And so we're making that as easy as possible. So that's not just a technical feasibility, but also a business imperative that we're seeing. So that is very helpful. We also, we really come with a lot fewer extensions and instructions, which is a very modern design approach. The other architectures really took an incremental approach, right? So they started with a base once upon a long time ago and have steadily built on top of that. And when you use that architecture, you get the entire thing. Pieces you need, pieces you may not require. For RISC-V, you get, this is a modular build, so you can take just what you need for your particular implementation or workload type. And that simplifies things not only for your implementation, but for the ecosystem that's depending on it. And I would also point out that, this week you probably also saw the announcements around RISE. RISE is a directed fund that is going to be investing specifically in some of the areas to support RISC-V ecosystem to accelerate that journey. We're continuing to be, RISC-V is continuing to be the center of gravity for all of the ecosystem to keep us working in concert and harmony. And RISE is going to take on a lot of the additional areas around development tools, language runtimes, firmware, kernel and virtualization, compilers, toolchain, simulators, emulators, these types of things that are really helpful to bring the rest of the ecosystem quickly on board.
Yeah. Just following up on RISE, I saw that announcement and I thought it was super interesting. Who were some of the founding members there? We have Google and Intel as chairs, which is Google's not surprising. They've spoken a lot about their interest in RISC-V, but Intel, they have another. They are x86, and here they are showing up in full support of RISC-V. That seems pretty important. And you also have companies like NVIDIA and MediaTek, who are very deep into the ARM ecosystem. And I don't think I've ever heard NVIDIA talk at all about RISC-V. It seems like there's a pretty strong level of support across a wide range of the industry.
Yeah, NVIDIA has been on our board of directors for a long time, and they have been leveraging RISC-V as part of their microcontrollers for many years now. In fact, when they were contemplating the acquisition of ARM, you even heard Jensen stand up and say, regardless of where the transaction goes, we are continuing unchanged on our RISC-V strategy. So that continued through those discussions and continues today. NVIDIA is a deeply invested part of our organization. You talked about Intel and how it's interesting that they're investing in RISC-V while they have their existing x86 business. When you look back at, if it's Throwback Thursday, I think it's Friday today, but if you look back to Throwback Thursday back in 2001, the world was frustrated that, Microsoft was gleaning licenses with every piece of hardware sold. So everyone said, well, hey, what about this Linux thing? And IBM, who, by the way, had a formidable software business, planted $1 billion flag on Linux and said, let's go. We can have both proprietary and open. So Intel comes along and about a year and small change ago, planted $1 billion flag on RISC-V, saying, you know what, we've got a great x86 business. We're not threatened by RISC-V entering into the space too. In fact, it expands our opportunity. In particular for Intel, they've got multiple lines of business, a foundry, right, that they'd like to fill. And, for those organizations who have their own architectures, whether it's, the stuff that NVIDIA is doing or things that Intel is doing, having a additional architecture to work with feeds into their business model and actually supports their business model. It is not, something that they feel is going to cannibalize their existing business.
And on the software front, I'm just circling back to that. I think in the early days there was a lot of I don't want to say hobbyists, but enthusiast interest volunteers in the community. But it seems like there's been a big shift in the last few years where you're starting to see enterprise software enterprises start to contribute meaningfully as well. I noticed Red Hat was in the Rise announcement as well. It, are we firmly in that sort of past that transition point where you have a lot of interest from institutions, enterprises, corporates investing in the software side, committing, contributing to the project?
I think that we are growing on all fronts. We have more than 3,500 members today, many of whom are, seated in multinationals or startups. I mean, the barriers to entry in building a meaningful business, with a microarchitecture are profound, and those barriers are gone. You no longer need millions of dollars to invest in all parts of that, whether it's the engineers or the lawyers to negotiate an agreement. That's not required anymore. Anyone can participate, and that's what's going on because the opportunity is huge. The opportunity in automotive for autonomous or assisted driving, the opportunity in data center to add AI for competitive differentiation, the opportunity from, in your cell phone, right? There's like more than a dozen microprocessors in your cell phone. Some of those are quite probably will be RISC-V, right? Are already today for many. You look at the Wi-Fi and the Bluetooth capabilities in your phone, many of those are RISC-V already. NVIDIA has been shipping RISC-V with their GPUs for years. That's not how they advertise their product. Hey, come get my RISC-V microprocessor. That's not the sale point there. So the software ecosystem is coming on board quickly because there's that collective interest. There's that collective strategic value to their organizations, as well as to the folks who are within the RISC-V community to upstream to those particular open source open source software or other key building blocks. So you see a lot of that today. In fact, we've had to re-architect our entire slide on, what does our software ecosystem look like, because it's starting to kind of burst on the sides, and the logos are getting smaller and smaller as we cram more onto the page. But overall, are we seeing more hobbyists or more multinationals? The answer is yes, we are, across all fronts. Whether it's new entrants to the field, the VC community continues to be pretty hot on RISC-V. In fact, we're getting more calls now to talk to institutional investors as well. So folks who are saying, hey, Dell, what are you doing on RISC-V, right? After their CTO started talking about, RISC-V, yeah, HPC, that's where the future is going to be. After you hear from, folks that, name your favorite multinational or hyperscale that are starting to talk more openly about where they're leveraging RISC-V. The reason they're choosing it is because, there's unlimited opportunity. The ability to innovate and that freedom of design is something you just don't have on another architecture unless you, are Apple, right? Like, you don't have that kind of freedom because you don't have that license. You don't have that transparency and visibility to really make those kinds of changes. And many of these organizations, whether they're large enterprise, hyperscale, OEMs, or systems providers, are digging in deeper and designing their own microarchitectures.
So you touched on this a little bit. You highlighted a couple markets, and that's been something that Jay and I have gone back and forth with, just talking about where we see kind of these pockets of opportunity, for RISC-V. So one, I want to talk about that, but in light of that, I also, as we follow this thread about software, and I agree with you in terms of the momentum that you're getting, do you feel like there's a risk? I didn't even mean to use that word, but a challenge that RISC-V goes to too many places? Like, could it? Is there too much diversity? Like, would that be a bad thing, or is it really just let's focus on these use cases now, and then let it go to all these other places, meaning let's get the software support for HPC or AI or automotive and build up the standard there. But because it's so flexible, there really are a lot of places it could go. But I'm sort of curious how you see the markets, right? It's not going to be one thing. There's certainly a lot of opportunity, but I also am concerned that it tries to do too much at a time where there are some very low-hanging fruit of value.
So if you're on an 8-lane highway and you're told, listen, we got to let these 3 lanes go first. So the other, these others are, you're just going to sit there and wait till they get further down the track. And you're in a different lane, but you're still going to have to wait. It's not like you're going to route into that lane. It's sort of the same thing. If you're a stakeholder in one particular area, you're less affected by what's going on in these other areas. So if you're an embedded or data center, you're not running necessarily on the same stuff because we're not building the extensions for just one piece of that portfolio. There are some that are more useful to others to different groups, but that's why we have 70 different groups going at the same time. So all 70 are running in parallel. All lanes are open. And that, it's not a scenario where you ask one stakeholder to put their needs on hold while you go address another one. It's an arena where those interests have some overlap that we should do them together. And that's an area where there's enough distinct interests that we have the breadth and depth across our community to work on all of them. We have more than 11,000 engineers in our community today that are, sleeves rolled up, hands-on code, running at this every day. There's no, you can't go to a company and say, like, I appreciate you're in the data center space, but we're going to go work on embedded for a while. And we'll circle back later. They're not going to wait. That's not how business is going to work. And so, we are able to pursue multiple of these at the same time. And that's why the internal governance and across these groups and engaging in these groups is so important. If you're developing for something that, hardware takes time. If you're developing something for a data center that's coming out in 3 to 5 years, you need us and want us working on that collective ecosystem at the same time, as well as the base building blocks to get us there. And you want to be inside the kitchen looking at what ingredients are going into the soup so that you develop accordingly and are in compliance with that specification as it's ratified. So those, that's part of the strategic advantage right there. Now, I will say that the robust ecosystem needed in enterprise is different than the workload by workload that you tend to see in embedded. So it is more challenging, and it does take a little bit more time. RISC-V certainly did get its roots and running start in embedded and in that smaller form factor space.
So if I was to say, I think I know your answer, but right. So the question at broad is like, what markets are ripe for RISC-V? I think you would say all of them, right? There really isn't a place where it can't go. And then I guess more specifically, I haven't dug into the technical depths of this as much as I'd like to, but there isn't any workload that's off limits for RISC-V.
That's correct. And there are things that we're doing horizontally around security and safety that will underpin many of these workloads simultaneously. And there are features and things that we're finding in some of the high performance stuff that is very applicable also then to some of the low performance or lower power consumption types of implementations. Now, RISC-V International doesn't do the implementations, but we are cultivating, a whole test suite of compatibility that is very helpful to the ecosystem. We've got one of those ready to go today, and we're coming out with more. And those are the pieces that will ensure that compatibility stays intact as you go to market.
Okay.
What about geographically? We just talked about industry. What about geography? Where are we seeing the most adoption of RISC-V?
It's interesting. I've been here for a little more than 4 years, and across that time, I measure it every single month. Where are we geographically, right? And we have remained consistently spread about a third North America, a third Europe, and a third APAC. So it's been pretty even. I would say that the most commercial activity has been North America and APAC, with the most research type of activity going on in Europe. Now, many of our stakeholders, as you can see, are multinationals, right? So they, have interest in many different geographies and markets. We're seeing increased activity in additional regions that are, not kind of the primaries in those three, such as a lot of investment going on in India. While part of APAC, we're seeing like much deeper investment going on there. And so those are the types of things that we see, as well as Latin America, by the way. So we're seeing a lot of those types of activities really start to cultivate that global sense of, hey, this is where I go to participate in, global partnerships, development partners, channel relationships, markets, and other opportunities by engaging in this particular open standard.
Interesting. And I suppose I have to ask about China. From my experience, it seems like there is just incredible, immense interest among the thousands of fabless companies in China today for RISC-V. I think in a lot of senses, they were some of the earliest adopters, at least on the commercial, broad-based commercial terms. Is that continuing? How is RISC-V being received in China?
Yeah, RISC-V continues to be as strong as ever in China. One of the things that I really appreciate is the level of contributions that we see coming from China as well.
Yeah.
It has been fantastic to see them deploy entire development labs towards contributing to some of the base specifications and things that are transparent, available for everyone to engage in that global sort of appreciation of artifacts. So they continue to be both contributing to the open standard and to our work groups and to all of our efforts across the board, as well as we continue to see a lot of progress in the community there, ranging from data center to AI ML to and data center and cloud, as well as some of the advances that they're making around embedded. So they certainly are doing very strong on volume. And have been, some of the earliest ones to get into production as well.
On this geography question, just the way that that RISC-V is structured and its architecture, right there. You mentioned diversity versus fragmentation, which I think is a really great point, and I assume that kind of translates as well geography, right? There isn't going to be some rogue island that China is on with RISC-V or Europe, right? While they can do their own things because it's flexible, there's still relatively going to be a base of standards that's consistent, right, across geographies.
I've actually spoken with governments in many different regions and countries. The draw of participating in a global standard to have global development partner supply chain and opportunity, meaning markets and customers, is far stronger pull than the need to, kind of have their own. Because if you say you have your own like country specific RISC-V ISA, how far are you going to go with that?
Mm-hmm, mm-hmm.
Right? I mean, no one's going to want to work with you, right? Like they're not. How are you going to get development partners and markets and grow an ecosystem? No country can afford to do that because you leave out the potential and the opportunity of engaging globally. Whether it's what comes into your product or where you can sell your product, and that's if only we all had the same electric plug adapters, we wouldn't have to carry those in our travel kits, right? Like that, there's an example, right? But this goes a bit deeper than that. And, those are lessons that we've learned in adopting global standards that can really rapidly open up those opportunities.
Yeah, that makes sense. It's interesting. So I want to just circle back to the RISE point again, just because I feel like I mean, it got good publicity, but perhaps not as much publicity as I think it deserves. But is it sort of correct in the interpretation of that's a big milestone in moving this ecosystem forward? And I say that because I get in a lot of conversations with companies that compete roughly with you architecturally, and there's always been this sort of question of like, all right, is it inevitable, right? Is it just a matter of time? Because that's what a lot of them hear, right? They just hear, well, it's just a matter of time for RISC-V. But it feels like RISE and its supporting members, and I have to imagine there are people deeply involved in the RISE community who didn't want their name on that list for strategic reasons. But that this was sort of a big milestone and I guess a big moment, right, for this ecosystem.
I think it's a significant level of interest in shared investment. I think that the larger picture of the rapid progress our ecosystem is making may have just been going on quietly in the background and not recognized and appreciated by, kind of the larger industry view. We've been progressing a lot of these pieces. The portions that RISE is helping out with are some of the underlying things that are needed by the whole community to fast track or accelerate the rest of the workloads, right? So it is huge and it is a great investment, and it's a testament to where we are and the strategic merit that folks place on RISC-V. I see it as an accelerator to the ecosystem, an ecosystem that has been growing very steadily, hundreds of different packages and libraries and other, operating systems and tools. I mean, you saw last year, the announcements around Android on RISC-V. You saw announcements from Qualcomm already shipping 650 million cores. I mean, the volume's already been out there. And based on the announcements, you have to, put two and two together to understand that these companies aren't going into production without the ecosystem that's going to run on it. So many of these base loads and things have been in motion or over the finish line for some time. And it's the acceleration of the remaining, essential elements that we see as getting a significant boost from RISE. And so we're extremely grateful for it. But it is something where it is moving us forward together, as an industry.
Yes. Interesting. Okay. Last question. I think I know what you'll say, but just curious. What do you think the single biggest hurdle at the moment is for RISC-V?
The single biggest hurdle. Well, let's see. There's always chicken and egg syndrome, right? Like, do I build it and go to market, or do I wait for someone else to do it first? Or is the ecosystem there, or will the ecosystem be there when I get there? And so it's timing. So the biggest challenge for many stakeholders in, kind of selecting RISC-V as an architecture is timing. They have very specific workloads. And so, this speaks to ecosystem. Is everything I need there and ready to go? We're at that tipping point across many different industries. And so, in this year, next year, the following years, where you're going to see a tremendous increase in the volume across many different sectors. So that's something where, I think some of our colleagues at another architecture said, RISC-V, it's going to take them decades to catch up to us. It took us 20 years to do this. Like, it's not going to take us 20 years, right? Because we're not just one company, like, aiming at this, like, target together. We're many companies going collectively forward. So, what may have taken decades before, we see within sight, within 3 to 5 years. Well, that's about how long it takes hardware to develop too. So this, we're just at the beginning, but we're fundamentally changing the course of where computing has been and where it's going.
I think that's a great point and conclusion. And you're totally right. I mean, I feel like momentum at this point, just sheer conversations that's having in in the semi world is really at an all-time high. So very, very interesting discussion. And thank you very much for coming on. We really appreciate your time.
Thank you
This
very
has been a
much.
lot of fun. Hope we can catch up again soon.
Yes, for sure. And thanks for listening, everybody, and we'll catch you next time.
Thanks, everybody.